Test, test, test. I don't know why the gain on this thing is hello. Oh, wait, actually, I know what's going on. Test. Error. Oh, wait. Hold on. Always something. God. If the aperture lever What is the aperture lever? I didn't even do anything. That's weird. Okay, okay. For some reason, the the lock was being weird. Okay, it was a demo photo. That's fine. Okay. Okay, all is well. Let's turn it off. Put my storage back in. Okay, that was annoying. Oh yeah, yeah, bro. All right. Okay, so this is my custom. This is my custom printed circuit board. It's been assembled, and then we have. Here's what we have. So we have. These. It's actually probably fine if these end up getting shorted. Okay, so let me just explain some of the I/O on board. All right, that's actually fine. We'll just go as close as humanly possible. Okay. So the whole idea is we have a USB cable, and the USB cable is actually, when I was assembling this morning a little bit, I realized this was actually a terrible decision, because the only reason why I did USB was for power. This transmits no data. This is not a data. There's no interface. There's no nothing. This is really not for anything besides providing 5 volts to the Raspberry Pi Pico. Now, the reason why I would have switched this out for basically anything else is that, first off, it's huge. But all right, I actually kind of want to just get to work because I'm getting a little pissed off. All right, anyway, so that we have DC here, and we have here this little jig that I made. So let's see if we can maybe get it to like 105 without slipping. Okay, so we have basically a 2 amp 5 volt wall wart, which I've broken off into a terminal block and a barrel jack. So we're going to be plugging this barrel jack in here, but before we do that, because probably having a regulator on here would have been good. I did a simple test between making sure that I wasn't shorting 5 volts and ground by testing the 2 prongs of the DC. But the biggest concern here is going to be this MOSFET. This MOSFET is apparently going to drive 5 watts, and I'm just concerned that I didn't realize this thing was going to be so tiny. So I think if anything is going to burn up, it's going to be this MOSFET, because Yeah, I'm quite concerned actually about Q1 here, but we're gonna test this out and see what's going on. So let's get it all hooked up, and we'll have to write some code. So I'm gonna need to get a USB cable. But the first thing that we need to do is look at this. Okay, so we're gonna take out this because this one is gonna go to the camera, but this one is gonna go and be our signal pins, and uh, and these colors are actually terrible. But they'll have to do. So let's see. If we broke it out, we need to remember the documentation. So let me actually open up the code and remember. Um, okay, here we go. All right, so I could switch over here. The pinouts, there's a TRS. I don't like JST port used for connecting GPIO from Pi Pico to the board. The tip is only used by the Pico and is for turning on the optocoupler. The ring is used by both. So basically, let's just get a multimeter and test if that's correct. Because my guess is that, because I forget which is which. So let's just do some tests. Okay, so do we get... You probably won't hear beep. Okay, because I think I have noise reduction on, but needless to say, we got a beep. All right, so white, I would assume, is the tip. Okay, white is the tip. All right, so let's just say the on the note on the Pico or the the TRS breakout cable. White is tip. Red is ring. Black is sleeve. Okay. So just test just test that just in case, but I'm almost positive that that's the case. Okay, and then black. Okay, so what we can do is look at. Okay, so the sleeve needs to go to ground. So we're gonna ground this, and then let me actually demonstrate something on the camera. So, let me get some tape. How many tape? Wait, actually, this might work. For now. It'll probably come loose. Okay, so let me just show one thing that I've done with the USB before we move on. So the USB is hooked up to from here to here, and basically what we're providing it to is pin 39 of the Pico, which is VSys and ground. And so interestingly and thankfully, actually, because I want to program this while it's powered, or be at least have the option. Luckily, if I plug in a USB cable to the Pico, it's... Oh, wait, this is the Pico 2. This is actually the Pico 2W. I need to go get the other guy. Because I don't want to... I don't want to switch anything up. Hold on. So I'll be right back. I just noticed that. So give me a second. All right. Okay, so one thing that I immediately noticed. So this originally was for our test. Um, so VSys. Let me just check the pinout again. Pico W pinout. Okay, VSys is pin 39. All right. We're good there. Oh wait, this is the wrong thing. Oh, this is going to be so confusing. Okay, whatever. All right, so we have power. And now here, we're going to want to ground this. And what I'm thinking is we want to just do this. So let me see if it's visible. All right, whatever. So luckily, and this is something that I only noticed a while ago. But the square pins on the Pico mean that they're grounds, which is really convenient. Dude, the Petri dish video is blowing up. The PCB. All right, so this is a little bit awkward. Let's take this. All right, maybe we'll do this. All right, so this is gonna go here to CN2, and now basically, we're gonna write a function. Okay, we're gonna start writing the software now. Actually, I'm gonna keep this here. I'm gonna get this out of my way. All right. So okay, so we're almost ready to power this thing. Actually, you know what? Let's just power it. Well, okay, wait. Here's what I'm gonna do. Before I actually power it, because powering it shouldn't do anything, because that MOSFET should hold. So, I mean, that's just how it works. So, let's just see. Turn on continuity. Turn on sound. Test it. Okay, now I want to test pins 1 and 4 on the USB. No short. Okay. So that's good, right? Because if there was a short, we would expect it to be all around. Like, it doesn't really matter. So let me actually look at the PCB design and see, because I also want to make sure that there's no short between, what is this? Trace. This is going to be from, because if I do this, I'm not going to get anything, right? Okay. I don't know if it's like an oxide layer or what. But so be it. That's kind of annoying though. Yeah, there must be some sort of oxide layer on the thing. All right, but I guess if I just test. Okay. I think I'm ready to do it. So we're just gonna turn it on and power it. And let's see if I can get this over here. Okay. So hopefully nothing catches on fire, right? Okay, great. Well, that's good. So this means the Pico is powered. Pico's not getting hot. All right, so we're all good there. So now let's just open up the code and write a little bit of code that, why is this mouse here actually? I don't really need this mouse. Okay, so let's switch over. All right. Okay, wait. So actually, and then one thing I want to say is that we're gonna have the white is tip, and then let's say Pico to Pico W pin. Let's figure that out. So that's gonna be the white is on the bottom. It's pin 16. GP 16. Red is ring GP 17. And then this is ground. And it's going to be 23 ground. GP 17. Because when you refer to, let me ask, okay, so let's just write some MCDC2 test. Okay, here we go. This is kind of what we want to do. So this is going to be PCB test.py from machine import pin def on off. So wait, first we'll do constants. Are there constants? I don't think we need a constant. So we're just going to say that opto pin is equal to 15, right? Is that true? Let's close all this other stuff. We're actually going to get to cable 16. Bet pin equals 17. Right? Okay. Let's go back to the README, just double check. Let's close all of this stuff. Okay. So actually, can't we just do this? Bro, MicroPython is dope. MicroPython is actually so sick. RP2. Is it just time? Okay, so what we're gonna do is just do. And then hopefully the LEDs should turn on. That's what we should expect to see. So wait, but let me just so wait, how do I run this thing? I gotta. No, I think I just want to do this. Okay, so I need. Oh, I forgot to get my USB cable. Damn. Okay, I need to get a micro USB cable. Okay. All right. Put this bad boy in. No sound. Let's try to connect it. Connected. Okay, great. Wait, exception. Oh, it's dude. I swear this Atto thing just like constantly like in every shell that opens. It's so annoying. I'm actually gonna go to GitHub really quickly. All right. Okay. Um. All right. So let's just copy the what? Oh, I know what happened. Can I paste? Oh, wait. Let's do How do I do the It's That's right. There we go. Right. Oh, it's String. Wait. That's interesting. Wait, what happened? Error exception occurred? Okay, wait, something's wrong. Oh, I forgot about this. You have to like close it and reopen it, right? It's ampy, right? Oh. I think I have to close this. What the fuck? I forgot all this stuff, man. Turn off out of pile. This thing is so annoying. Like, why the fuck do I have all this stuff? Come on. Java, bro? It's like, what is all this crap? Oh no, screen must have not let it go or something. Um 1, 2, 5, 6, 5, 7. Okay. Or wait. Okay. All right. So we're just going to type it in. Okay, good. All right. Thank God. Okay. So now, can I copy and paste code in? I don't know if that's allowed. Oh, nice. Good. Can I define a function? Wait, let's just try to paste the function in. Wait, shouldn't I do... I don't know what on and off... I don't think those are real things. Is that? I think that was like fake. Okay, I'm going to turn on... I'm going to plug in the power. I don't know why it's saying none, none. Okay, the LEDs are not turning on. But I wonder why that is. Oh, because... Oh my god. Ay, ay, ay. Oh, I might have shorted the freaking board. Oh, for the love of God. Oh! Oh! Oh, it worked! Wait, did you see? Oh, no, because you didn't see it. Okay, wait, hold on. Oh, I'm in an error state again? Something is on the fritz about this camera. I don't know what happened. I don't know if I have to, like, take a picture when I start. It's so random. We should be good now. Alright, check it out. Pin.value 1, pin.value 0. Alright! Okay, that's so sick. Alright, so now all we have to do is basically... So unfortunately... is this gonna reach? It's like kind of tight, but maybe it'll reach. Okay, so let's unplug the power supply. I don't want to mess anything up. I'm always so overly cautious about this, but we're gonna plug this in. We're gonna put this. Yeah, it's too short. So we had an extension, but the problem is I cut the extension to make the thing. But we can so that means we need another one of these female TRS connectors. Do I have a female TRS connector? Or actually, you know what? We have like another one of these, so I can just go find another one of these. I'll be right back. I just grabbed the first one I could. So it's kind of long, but no matter. Okay, so we're gonna go here to here, and then here to here. Let's get this wire out of the way, and then here. The MC DC2 port. All right. Okay, so the next thing we're going to do is we're going to try to take a picture. So we're going to do an on-off on the opto pin. So, so actually, technically, I shouldn't even need to. Okay, well, that didn't work. Well, it's definitely working. All right. Cool. Yeah, we didn't need to. So the whole board works. We can now move on to CAD because it all works. There's a lot of little CAD things to do that are kind of annoying. I mean, they'll actually be pretty fun, but basically, basically it all comes down to now integrating everything together because the board needs to go in a specific place, and then the Pico. What does that sound? Interesting. That is really weird. Oh. That's really weird. Okay, so it's making a high frequency sound, and it's making a high frequency sound from the USB cable. Okay, wait. Let's try to. Okay, wait. So let's write a code that does the whole thing. All right, so we're gonna plug this back in. So that's in. Make sure that the cables are right. Okay, so this is the input, and then we have the camera's output. Okay, so here's what the code needs to be. The code needs to be, so first off, does on-off work? And if so, or if not, why the hell not? Because it doesn't even make sense to me. Okay, so dude, this thing got bent. All right, plug the USB in. It is definitely making a sound. It's very interesting. So I should be able to just do this, right? Or is it Yeah, see, I don't know why that happens. But if I close this, can I reconnect? I don't understand. It pisses me off that that doesn't work. I don't know what that's about, but I keep having to like reopen it. Especially because these damn extensions take so long. I don't know what it is about copying and pasting in code that's so annoying. If I just do it line by line. We actually don't need that one at all. Okay, wait. Oh, dude. I mean, it's just so annoying. Wait, what if I run, then LED, or on, off, LED? Bro, what? This thing makes no sense, dude. Run current file. Is this just a different button? I am confused. No, see, that is the right thing. I mean, what? That's why I don't like microcontrollers that much. I mean, I just feel like I have no idea what's going on. Wait, is time.sleep in seconds? Okay, it worked. Okay, it worked, but now if I do this, it doesn't work, right? No, it does. Okay. So what we actually want to do though is the whole routine is going to be fet pin dot value 1 on off. Wait, can we try this before we try that? If we turn it to manual, then this should work. Sick. Dope, man, dope. That's so cool. All right. So so what do we need to do now is like see how low we can go. And then we can probably make that better. So oh yeah, so let me add a note there that okay, so all the settings need to be set up priority. Which is going to actually guide the top plate design because the top plate. Okay. So you should be able to do this. Okay, let's try this. Nice. Oh my god. Okay. All right, so we can end the stream because we're done testing, and we can just get back onto wiring and CAD. So I'm wondering how. Okay, let me get my iPad and just. Okay, so let's wrap all this real stuff up and get back to the computer. Where's my lens cap? There's my lens cap. Okay. All right, so we won't need this for a bit. It's pretty sweet that PCB works, man. First try, baby. So, all right, so what are we doing now? We're just gonna hop into, we don't need this. We don't need this. It says that these are grounded, right? But that's actually not. On mine, it's not grounded. Only the bottom two are grounded. But as long as we're just M2. Okay, so let's just get into TL draw and sketch out how we want this thing to look. Okay, so this is what I'm thinking. So we have the box. And then there's this little base here. And then there's going to be a little, well, there's really going to be like a door here with a little cutout. And then this is going to be like this, this, this. This is the IO. And then there's a little magnet up here. And what I'm thinking Or actually, it's the other way around. It's more like that. And then out the back here, it's going to be a cable. And this goes to the wall. And then out of here needs to come down into this one. And then what I'm thinking is we have like the Pico just like mounted to something like this. And yeah, okay. All right, let's just go with the simplest thing and then see what goes wrong. So this is the Pico. And this is going to go like two cables go down to this thing, the USB. And then three cables come and connect into here. Okay, so if we're looking at it like I don't know how we want to attach it. Maybe. And then the other thing I was thinking of is like maybe this top part actually is like this, and there's just and there's like a holder here. Okay, so I need to get some water. Okay. I think I'm gonna go walk around the block, man. I need to go on a walk. But so wait, so we M5 by 15. That's a little short. $20. I don't think this is exactly what I want. Oh, actually, this is kind of what I want. Because then I can put any M5 bolt that I want in there. And they're rubber. I want to buy this. I feel like it'll make it feel way more premium if it's on like a thing. Is there a drawing though? Oh, that's a good enough drawing for me. So yeah, so instead of just like this, because the thing is it's sliding around on the plastic and I just don't like the feeling. The thing is it's gonna be overhanging a little bit. So I'm wondering, do we want to make it just a little bit bigger? This is the wrong one. The which way does it which way does the bolt go? So it's smaller at the it's kind of weird. But so that means 25 in diameter. If we were to go here to the base plate, I feel like that's fine. That's not that big of a deal. We don't need to change that. Okay, I'll be back in like... Wait, hold on. Let me drink some water. I'm like so thirsty. Okay, and then top plate. Can we look at top plate? Oh, this is a beefy ass boy. Oh, but this is... Okay, this is like... This is one option. But the thing about this option is... All right. I'll be back. Okay, a big part of it that's actually missing that I really overlooked is, let's say that we do have this computer plugged in, but how do we actually start a program and set the settings and everything? You know, because the actual, okay, I shouldn't have closed the code because we're not done. We need to work on this. Is it's going to be like so like let's say time lapse. It's going to be the snap time total time. So basically you provide time lapse every time lapse every 4 we can do this. Oh, I love that this thing is still completely borked. Yeah, like what is this, dude? How did it, bro? I wrote the issue on that. Okay, okay. So basically, um, wait, that's actually a terrible interface though. Um, because what do I want to be able to do? I'm using this thing. I'm working back from how I would want to use it. I'm gonna be like, I want to take a 36-hour. And is this gonna do a floating point thing? Like, can I? Oh, oh. That's okay. Let's just do this. Wait, does print work? Oh yeah, it's hours. What is time that ticks add? What is that? What is all that? What I'm guessing is that it's like more. Okay, cool. Wait, can we try that actually? Okay. So ground, VCC, ground. Oh, sick. Wait, what's the difference between that and the other one? Okay, so I need to make some wires, I guess. So I need to use red, black. Okay. Bro, you guys gotta go watch my video, dude. I just made a dope video. Okay, so interestingly, purple. Okay, purple is VCC. Okay, so wait, before I actually plug any of this in, let's just do all the stuffs. So wait, first off, you don't need this. Let's just unplug it all. All right. Okay, so even this we don't want. Right now we're just gonna test out the screen. Okay, ground. Bro, I might finally hit 450. I knew I'd break through. Okay, so wait, where's the... Oh, wait, can we do this too? We should do this. All right, 3v3 out is pin 36. 1, 2, 3, 4, 5. Okay. Ground. Go anywhere. Okay. DN. Green. $11. At 15. clock. I don't have enough colors. Let's just do red again. Pin 10. Okay, clock CS. Yellow. GP9 is 12. 10, 11, 12. Okay. DC blue. Jeez Louise. DC goes to pin 8, which is 11. And then reset. Reset could be white. I don't see any issue with that. This is kind of fun. I haven't done anything like this in a while. Of like, you know, makes it a little bit more fun. GP12 is pin 16. Okay. And then finally, okay, let's do that. So that's gray. Okay, so 13 is 17. Okay. So we got it all hooked up. I want to know what the difference between those is. Okay. Oh. Oh, because it's, yeah, okay. Okay, so let's install it. Probably is going to fail because you can't paste anything into this freaking thing. I don't think I wanted to do that. Wow, that was so unnecessary. Oh, really? I didn't know that. Wow. Oh, wow. Okay. La na 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 na. All right, so let's just download the thing then. So we don't want this one because it's going to be too hard to install. So, but there's all this stuff, right? Like, oh, geez. Confirm it's not. Yeah, it definitely is though. Oh, what? Oh, because we gotta disconnect. That's so annoying, man. I think you're not supposed to put it in lib. Oh, it does? Okay. Wait, what? Oh, I'm silly. Just to do this. Nice. Okay, so it does work. Okay. All right, so we can import the library. Now we just need to figure out how to. Now we just need to run that script, right? I pulled it out. Wait. Oh, wait, can I just edit this code? Dude, that's actually crazy. Wait, does that work? That's amazing. Right, so we're not gonna actually do this. Okay, so obviously that wasn't right. That's fun. Drawing text using converted PC BIOS bitmap fonts. Drawing text using converted TrueType fonts. Drawing converted bitmaps. Okay. Precompiling the font Python modules to .mipy files will significantly reduce the memory required for the fonts, even from the font size can be converted to frozen bytecode and compiled them. Okay, that's probably what the C library does, right? The bitmap font conversion. Oh, it's sick, bro. Oh yeah, that's the stuff. So where do I get a font? Is this a font? Sample ROM font, sample converted ROM font module, text font converter .py.i font bin -o fonts -f32 -l127. Oh, those ASCIIs, bro. I love these C libraries, man. I want to work on my Lisp compiler in C, but I don't have time. There's no time. There's no time. There's no time. Let me actually check my chat, bro. I don't know if anyone's watching. What's that background sound? Wait, what background sound? Oh, nah, it's just construction. If you're talking about a bunch of sawing, it's yeah, it's just construction. Okay, let's figure this out. By the way, hi Riley. Hi Riley. I hope everything is good. All right. What are we doing here? We are trying to figure out how to get a font. And I want to do it without ChatGPT. I'm actually like kind of tired of vibe coding. I just want to do it the right way and understand. So let's look at the example programs. Tiny hello. No, I don't want that. Fonts. Pages through all characters of our fonts. So, okay, so wait. If I just look up Russ Hughes. Okay, there we go. Okay, there we go. So, okay, so it's actually in... Oh, did I just miss that? No, wait, this is the C library. Memory view font. Okay. Okay, wait, so let's actually... Let's go back and, Wait, so this is... Okay, wait, hold on. Examples, Noto fonts. Lib, Rom fonts. Okay, so wait, here's the font. Okay, so this is the font. Okay, so I should actually be able to just... Mippy cross. Okay. What is Mippy cross? Mippy cross is a cross compiler which runs under any Linux unit and compiles .py scripts into... What is a .mpy? Let's take some notes. Let's just try to like learn something instead of just, because like coding has become too easy and you don't get the joy of learning like what's going on. And I feel like I need that right now. I need that. MicroPython defines the concept of a .mpy file, which is a binary container file that holds precompiled code, which can be imported like a normal .py module. The file foo.mipy can be imported via import foo as long as the foo.mipy can be found in the usual way by the import machinery. Each directory list and sys.path is searched in order. Okay, and it has a lower precedence. These MIPI files contain bytecode, which is usually generated from Python source files via the MIPI cross program. For some architectures, a .MIPI file can also contain native machine code. Okay, so I think what that means is that actually before I even need to do the font from ROM font utility can convert fonts from the font bin direct. Okay, so he's just saying if you want more fonts, you can go there. Bro, this looks beautiful, man. Look at that. I love these bitmaps, dude. Okay, so, but what is the... So I think, actually, I can literally just go like this. And go in here. Do I have to put it in lib? I might want to put it in lib. New file. VGA, what is it called? 8x8.py or something. And then I have this thing. And then, presumably, I'm VGA 1. Oh, did it format that? I don't know if that was allowed. Okay, well, that was identical. So it actually doesn't matter, I think. Okay, so now that I have that, I should be able to do LCD test import VGA1 8x8. And so that's my font. Now we can look at examples. Hello. Okay, import as font. Nice. What is TFT config? I don't actually know what that is. Is that in the docs? Oh, okay. It's just right. Okay, so that's something that we don't actually need because we just have it hard coded. That's okay. But it does make sense to just put that somewhere else. That's smart. So tft.init, what that's returning is it's returning this object. So what does our code do? Our code, it doesn't do a tft.init. Okay, yeah, so let's actually... because I don't know any of this stuff. So if I init tft.fill, yeah, okay, so if I run this, it should turn red, right? Okay, so init is because config 1, this passes a 1 to it. But then, well, this is kind of this is kind of a different one. Okay, so maybe we just don't need init. Okay, let's see if I just comment that out. Okay, so that worked. That's fine. I don't even care. Font text TFT width. Whoa, what is all this math? Oh, because this is okay. So wait. So let's look at the documentation here. Reference text. Here we go. Font text X0, Y0, color white, background black. Okay, so we literally could just do tft.text font hello. And then it should just work. Okay, so that didn't work because you actually have to provide color equals ST7998 white background. Missing positional required argument 4. I think I'm... Oh, you know what? I'm silly. Oh, wow. It worked. That's super sick. So... Wow, this is actually going to get really complicated. So I need to go get some buttons. Okay, so we're defining a user interface at this point, and we're going to have a couple of buttons. One button is to increment. One button increments. Oh, actually, we can't do that. What we're going to have to do is we're going to have 3 buttons. 2 of them for raise and lower. One for next option. Wow, dude, designing this is gonna be annoying, but it's gonna be fun. But it's gonna be annoying because you gotta actually make it work on the screen. So basically, because you gotta like, okay, so so what we could have is like, so Bro, I kind of want this device to be like medieval themed a little bit. I wonder how we can do that. This thing should be like ye old time lapser. Ye old time lapser. All right. So then in here we basically just want to say interval. Does new line work? Oh wait, but we're gonna need to do. So wait, hold on. Let's say. Can I do a format string? Um. Oh, I can do this. Oh. Wait, does this work? Can I just do this? I don't think that works because it's looking for a format specifier. That'll probably not work, right? Oh yeah, that just pointed at literal. So we want this, and then we want this to be, I think, x0 is going to be. There's probably something to facilitate this, but let's just do 9, right? Oh no, that's not right. We want y to be. Because isn't this a 8-bit 8 oh, so we can actually put 8 here. Okay, great. So now what we want to do is go get some buttons. Okay, let's get some buttons. Okay. 3 buttons. Let's do 3 different heights because we have it. So the high, the low, and then the medium. Okay. Oh, what happened to one of these legs? Okay. Here, we'll do it like this. Low, high, medium. Okay, so how do we detect if a button has been pressed? I don't actually know. Um okay. Um Debouncing can be for later, but wait, let me read this. When working with digital inputs, it's necessary to ensure that the pin has a defined state when the button is not pressed. To do this, we use a pull up or pull down resistor. Oh, connects the pin to a high voltage through a resistor. When the button is not pressed, the reads high. Okay, so we can just okay, so I need to go get a resistor kit thing then. So here, let's get a view of this because so we have 3 buttons and we're going to need 3 pins for that. So we can just tie 3 digital pins to high through a resistor. And then what's the difference? Is there any difference? Oh, wait, really? Many. So then I can just put it to ground and that's it? Oh, I didn't know that on-off worked. All pins except number 16. Oh, I closed it? Okay. Why not? That's kind of weird. Let's first define a callback function, which must take a single argument being the pin that triggered the function. We will make the function just print the pin. We will create two pins and configure them as inputs. Finally, we need to tell the pins when to trigger in the function. Oh, so you can do an OR on, okay, on the trigger. That's interesting. So for us, ooh, oh, this is gonna be weird because, um, okay, for now, let's not handle that. Let's just do basic callback. So, okay, so we're gonna say the, okay, so here is how I want the user interface to work. The interface of the LACD is 3 buttons. 2 are for incrementing and decrementing the time lapse parameters. The third is for toggling, for advancing to the next. Oh, but we can do something like you touch 2 buttons at the same time, maybe. Okay, so well, this is actually more time consuming because what we're going to want to do is we're going to need to keep track of where the cursor is almost. I guess what we can do is we can just have like a cursor index equal to 0, then like if, on callback. So let's do inc callback p return none. Def decker callback. Let's just call it CB. Def, advance, CB. All right, so we're gonna have 3 callbacks. And then we're gonna configure the pins. So let's just pick some pins. So what we're gonna do is we're gonna pull them up. So let's get some wires. All right, so we can switch over to this while we do our ASMR wiring. Okay. Oh wait, let me get some pliers. Oh, let me get some snips. Damn it. Okay, so I'm back. We're gonna go and cut this like that. That seems good to me. Then actually what we want to do, I'm gonna like squish it, pull it out, and we know exactly where to do it. And pull this out, fold it over. That might be a little bit long, but it's a little bit long for my taste-amundo. There we go. It's cool that they have a built-in pull-up. I had no idea. I thought I had to manually pull it up. That's actually so clutch, dude. Okay, so now we should be able to just let's just do three kind of long different colors. That should be good. I think actually, hold on. I don't know if this is gonna be that easy to do. Let's see if we can do this. Because I think that it's not double whatever. I forget what it's called, but if I do this and this. Oh, wait. I'm pretty sure that this. Yeah, so these short. So they go on the even the opposite sides short if you press the button. So I could just do that. If I so choose. Okay, for right now, since we're sort of just testing, let's do these. Actually, let's do that. Cutter. All right, this is a pain in the butt, but let's just get on with it. Get on with it. All right, cool. So now we should be able to. So we have. So we'll just figure out what pins these are. With the okay, so we can switch back over to here, and we should be able to figure this out. So it looks like we're doing. Hold on, I need to do something. Yeah. Hold on. All right. So we're doing pin 21 is down. 22 is, wait, no. 20 uh 20 is up and 19 is next. All right. So now we have to do this thing where it's like a down is equal to pin 21 pin dot in, and then do I have to do pin dot pull up too? Yeah. Oops. All right. So we've got that all squared away. We just need to attach them, right? So down dot irq trigger equals pin dot rising irq rising, and then handler equals Decker CB. Oh, we need to attach them after the fact. So we can duplicate this. Actually, can we call this Decker Inker and next? That'll make this a lot easier. So first up, this is Decker. And then we can go like this. So this is going to be Inker. And this is going to be next. Decker Inker next. Decker Inker next. Everyone say it. Everyone say it. You have to say it. If you're watching, you have to say it. Decker Inker next. All right. So okay, so wait. So cursor index um um so wait, so hold on. Let's see. How can I do this actually? Okay, so then we just want to do like text height equals text width equals 8. Then 4 param in params. And then actually, do I get a... I wonder if I get this. Oh, I do get enumerate. That's sick, bro. Are they square? I don't know. Let's try to run it again. Wait, why isn't that? What happened? Oh. Um, cursor index is equal to cursor index plus 1 mod and params. So if it's 0 and you add 1, then you take, 1 mod 2 is 1. Okay, then you do it again and you're gonna get 2. 2 mod 2 is 0. Okay, so we're at there. Okay, that sounds good. Okay, let's try to run it. So basically what we want to do is, wait, this should just work. Let's see. But actually, wait, hold on. Well, okay, we'll still see if it works. Okay. So that didn't work. Okay, none of the buttons worked. Oh, Local variable. Oh, wait. How do I do global? Do I have to do global? So first off, did I get the pin numbers wrong? Next. Oh, it's 2019-18. Okay, so that one's not gonna work. Inker though. Okay, so let's just hard code this right now. Then, oh wait, actually, can I do a dictionary? Wait, what happens if you enumerate this? Okay, cool. So it enumerates the keys. So then we could just do like params uh cursor index plus equals 1. Print key error is 0. Can I index that though? Okay, so um Oh, Python is goofy. Hell, bro. I'm sure there's a better way to do this, but oops. Oh yeah, okay, wait. So I'm willing to ask chat that. Oh, I have to do that. Ooh, that's smart. I like that. I don't think I have that font. Do I have that font? Let me look at the font. Where's the font? I don't think I have that font, actually. Here we go. VJ 8x8. Oh, wait, but we want to go to the README. But we have this. Prefix. Okay, I'm done with that. That's cool. That's a nice feature. I didn't think of that. Wait, keep IRQ handles flip. Oh, that's interesting. I don't want to do that. Let's see. Something happened. But it's not redrawing. That's right. Okay, so we need a big draw loop. I get it. Oh, I get it. Okay. Okay, so we haven't. So the chat is right that we need to redraw the scene. So we get the current time. We handle next. If next pending. Oh, okay. Fine. Okay. Okay, I'm down to do this. This is actually chill. Okay, so like... Okay, so we want to do a def draw. Okay, last apply. Oh, and then, okay, all right, fine. All right, I'm chill with that. I actually like that a lot. All right, so let's see. This should just work, right? Oh, so we need to call draw. Oh, wow, it just works. That's pretty sick. I lied. I don't know if I want this. Um, Oh, that's a lot of logic. Wait, hold on. Let me read it. Let me read, not the. When either button is pressed, falling edge on. Mm. Okay, so this is all good. This is all good. Okay. Okay. True. Pending inker, pending decker. Button ISR. Tiny allocation free ISR. Timestamp detect combo. Set flags counters. If the difference in the time between now and the last interrupt request is less than the debounce time, just skip this whole thing. And okay. If it's not, then the last interrupt request time is now. Then wait. I think my code as is before these changes is active high, right? Meaning that wait. Um Active low means that when the button is pressed, the pin's value is low. Yeah. So active low. Yeah. So released, the pin is pulled high. Pressed, connects the thing to ground. Okay. So chiliante of you. It's so fucking chiliante of you to be that chill as fuck. Okay, so this logic makes sense. If pin is inker, what does that mean? Okay, oh, so we have one callback for the whole system. If pin is inker, then last inker time is now. If the other is already physically down and close in time, then we chord it. If decker.value is low and ticks diff oh yeah, so we're gonna have to write a good amount of software for this thing because we also want we want to be able to cancel it if, 'cause, 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 ' If we accidentally start it, for instance. You know, it would have been easier just to host a web server. But the thing about a web server that's annoying is that then it's got to be connected to the Wi-Fi. And that's a whole thing, man. But honestly, it's pretty easy. We can definitely go with the bigger font. That's for sure. All right, so this code all makes sense to me. So I feel like okay, wait, we didn't read all of this though. Pending. Okay, so we okay. Okay, this actually is smart. Yeah, I like that. If combo armed, start time ups. All right, this is good code. I like this code. Okay, so if we stop it and then we run this one. Okay, so we can increment and then we so wait, the caret got removed. Oh, because of this fucking thing. Oh wait, it did work, but why did it take so long? Hold on, let's stop it, run it. No, that seemed to work. Okay, wait. I can't get it to trigger now. What the frick? Press a button, press the other button. It's kind of janky. I feel like we should just add another button. It's not hard to add another button. Okay. Wait, let's unplug it. I like this code. This is better. And then what is this going to be? This is going to be that last one there. 15. This code is more reasonable to me. But actually, wait, I'm gonna shift all the things down. 21. Okay, so instead it's going to be yeah, 21. It's gonna be these four. 21, 20, 19, 18. And then we should also do okay. Let's try it. Okay, that's pretty good. Oh, you know what I can do? I think I should be able to do. Oh, okay. Wait, so where did we see this? Oh, am I in a while true? Oh, I think I can do this, right? Try. Catch. Keyboard interrupt. Break. Does MicroPython try catch? Is that a real thing? Oh, it's accept. Okay, wait, hold on. So, oh, um, wait, so what was I doing? I wanted to, oh, I wanted to change the font. I wanted to import OS. OS dot. Oh, sick. How did I get that in there? Oh, I think I just did this thing. Oh, that's the sickest thing ever, man. So now if I run it, it should just be twice as big. That is sweet. Oh, that's so sweet. What other ones do they have? Wait, but they have 8 by 16. What is it? Width by height? Height is taller, width is... Yeah, I want to do 16 by 32. VGA 2. All right, let's try VGA 2 16 by 32. This thing is awesome, dude. That's awesome, man. Wait, why did it switch the? Wait, that's weird. Okay, I guess it doesn't matter, but that's weird. Oh yeah, because dicts aren't sorted. No matter. Okay, wait, is the screen at all in the? Yeah, you can see. So I guess what we want to do is make a. So we need to do a progress bar. Dude, this MPI, this MIPI remote workspace thing is awesome. It's actually awesome. Okay, so we need to come up with a housing for this and like. All right, so there's a lot that I think we want to do because we want to have a progress bar. Um, I'm sort of wondering how we're gonna mount this thing. You know. Yeah, I'm tired, dude. I'm tired. All right. Uh. I'll be back. let's just integrate the whole system. Let's just do that. So what we have to do, we're gonna need no more cables, no buttons, none of this, none of this. Okay. All right, so we got the PCB. This is nothing. We got the USB cable. Okay, so we got regulated 3 volts to the display. Now, what we want is the pinout diagram because I need to... Okay, VSys. Ground. It's going to come into here. Then, we're going to have 5 volts. Okay. And then this is going to go to here. And these pins, we need to check them again. It's in README. Pinouts. White is tip GP16. Okay, so this is white. Okay, then red is 17 and black is ground. Okay, so I don't know if you can see that. Get this going to there. This is going to here. Now the only thing that's left is the MCDC2 cable, which is long as hell. It's going to come to here. So now before we actually power it on, what we're going to do is, we need to just write a tiny bit more code. So in LCD, instead, wait. Yeah, change delta next pending, start pending. So let's just do start pending equals false. Then here, instead of just writing this text here, we're just going to do a start pending equals true. Oh, wait, we have to do global start pending equals true. And then if next pending, if start pending, we can do this, this. We can tab this in here. And what we want to do is we're going to neglect the time, the progress bar. I was getting ahead of myself. But what we need to do is we need to add this code. I think we just need this because I don't think we have math in here. So we're going to do math. Okay, and then we can just call time lapse. We should just be able to call starting time lapse, time lapse. And then here, what we need to do is give params, interval, params, duration. And that's it. That is how it works. And then I don't know about this accept thing, but can we just stop it? We're going to, let's see if it works just, without the power. So we're going to run it. Okay, so the screen turns on. Duration 36 hours, interval 30 seconds. Let's just click start. Oh, I guess the power was on. Wait. Wait. Hold on. It's not right. Where's the power coming from? The power is not, that's not good. Okay. Wait, let's try it again. Okay, so let's stop it. Let's run it. So my custom Petri dish time lapser is coming into existence. So this little screen lets me select basically like, okay, if I want to increase the number of hours of my time lapse, or if I want to decrease the amount of time of my time lapse. And then if I start it, what you'll see is this a bunch of LEDs is going to turn on. It's going to control this camera to take a picture. So watch. Okay, and then if I go to my stream, you can see the actual result of the picture. And so this is all going to go into a housing in a box, but this is basically the general operation of how it's all going to work. 40 seconds, pretty concise video. Let me listen to it. Time lapser is coming into existence. So this little screen lets me select basically like, let me try doing another take. My Petri dish time lapser is coming into existence. I have a little screen here that lets me choose the two parameters of this thing. And if I start this, these LEDs are going to turn on. The camera is going to take a photo. And then we can see the photo there. The LEDs are on, which is good. So the cells should be fluorescing. And then, in 20 seconds or however long, this thing is going to turn on again, take another picture, and just save it to that SD card so that I can make an animation out of it. Petri dish time lapser is coming into existence. I have a little screen here that lets me choose the two parameters of this thing. And if I start this, these LEDs are going to turn on. The camera is going to take a photo. And then we can see the photo there. The LEDs are on, which is good. So the cells should be fluorescing. And then, in 20 seconds or however long, this thing is going to turn on again, take another picture, and just save it to that SD card so that I can make an animation out of it. Petri dish. That's pretty good. I mean, the thing works. This is badass, dude. This thing just works. You know? All right, that's the stream.